Oh, good morning, Cisco cohort 4. Hello to all you synchronous and asynchronous attendees. And today we're going to be going through this access control list lab on configuring and verifying extended access control lists. And I'm going to do this on the real equipment because there's one or two things that Packet Tracer didn't work properly in this lab. Like, for example, you can't issue the command IP/HTTP secure server. That doesn't work in Packet Tracer because Packet Tracer doesn't run the real IOS. It's sort of like a Macromedia Flash simulation of what's running in there. So let's see. So let's take a look at this lab. Now let me go ahead and minimize this and bring up the Microsoft Word doc file. And this is the lab we're going to be working on. I'm doing this on real equipment. I've got 2 real routers and 2 real switches. We're rolling out PCA and PCB are going to be the VMware machines that we use here in the lab. And I'm going to first of all do what I like to do, which is I plugged all the wires together for this topology, and I've done a very minimal configuration on the 2 routers and the 2 switches. I've simply given them a host name, S1, S2, R1, R2, and I did a no shutdown on the Ethernet ports on the router R1 and R2. And I went ahead and went into PCA and PCB and gave them the IP addresses that were configured in this lab, the 10.20, 10.30, and 10.40 addresses that are on those particular devices. Other than that, it's completely unconfigured. And the reason is, what I like to do is do this. I'm going to go into switch 1. I'm going to do show me your CDP neighbors. Go to switch 2 and show me your CDP neighbors. So we can see, if we look at the front diagram on the front of the page, S1 is connected to R1 out S1's fast Ethernet port. Let's see, does the mouse work? Okay, oh good, the mouse works. So R1's S1's fast Ethernet port 0/5 is connected to the gigabit 01 port on the router, and S1 is connected to S2 from 1 to 1. Device S2 is connected back to S1 1 to 1, and S2 is connected to his host router R2 through S2's 5 fast Ethernet 0/5 port goes to the gigabit 0/1 port. Now, warning, Will Robinson on this lab, it assumes you're using the newer 4000 series routers, and their Ethernet ports are numbered G0/0/0 and G0/0/1. And in our particular routers, they're numbered G/0/0 and G0/1. Now, I'm going to go ahead and move my console connections to the router because we're supposed to do some router configuration first, and then we'll come back and I'll swing the cables back and we'll do some set up the VLANs and the trunking port and everything on the switches. Okay, so let's just check on the router. It should be R1 and R2. So if we go to the router and show me your CDP neighbor, router 1's only neighbor is S1. CDP only shows you directly connected neighbors. It won't show you the it won't show you one that's 1 hop away or 2 hops away or anything like this. So our connection should be good here. Okay, so on page 2, near the bottom of page 2 of the lab, we're going to do some basic configuration for each router. And I've already given the router the host name of R1, and you can tell because the prompt says R1. And then at the top of page 3 on my printout, sometimes it'll format differently on which printer you print it out on. There's a command there, no IP. What's the command that we type in to prevent the router? If you type in a misspelled name, it'll normally hang you up for a second. So we type the command no IP domain lookup. Okay, so wait a second here. I'm going to bring up my text file. I'm going to do a little copying and pasting to save time here. So he tells us at the top of this page here, we're supposed to configure no IP domain lookup, then do the enable secret class command to set that class as the password that you have to go to promote yourselves from the user exec mode to the privileged exec mode, and then assign Cisco as a console password, and then assign Cisco also as the VTY password like we normally do. Now later on, we're going to put in a secure shell encryption on that, and we're going to put a web server on R1. That's coming up later. And then a little step.f, we're supposed to encrypt the plain text password with service password encryption, and then put a annoying a message saying, get out of here, unauthorized users, and then save everything to the configuration. Okay, so let's see if I'm allowed to paste here. Uh-oh, I wasn't in the global configuration mode. Okay, let me go to the privilege exec mode and go to the global configuration mode and then see if we can paste it again. Okay, so all those commands look like went in properly. So now the passwords have been set, the banner has been set, service password encryption has been set properly. And now we're going to go to R2 and do a similar sort of a thing. So I'm at R2 and I'm going to go to the privilege exec mode and go to the global configuration mode, and we've already set the host name, so I should be able to just punch in all this other stuff. Okay, so now we're down to step 3, the middle of page 3, and we're going to go over to the switches and do some stuff on the switches. So hang loose 1 second while I walk over and move the console cables to the switch console ports. Because I only have 2, it's like you guys do this in the classroom, I only got 2 console ports that I can use, 2 communication ports that I can use. Okay, so there's only 2 possible ways to plug that in, the right way and the wrong way, and if I did it properly, S1 will be the top and S2 will be in the bottom. Okay, good. Since the only thing I've done on the switches is I gave them the host name. Okay, they have you go through a similar setup here on the switches, which I've already given the host name S1, host name S2, and then we're going to do no IP domain lookup, enable secret class, the line and VTY password, service password encryption, and banner message of the day. And if my copy and paste works properly, of course, I have to be in the privilege exec mode and be in the global configuration mode, and then it should work properly. So I'll go to the privilege exec mode, go to the global configuration mode, and I should be able to type in all these lines. So we reach the bottom of page 3, and then they tell us we should save the configuration to each device. Well, I'll go ahead and do that. I'll do a copy, run, running configuration, startup configuration. The first one, and to the second one, you can't do it from the global configuration mode. You have to be in the regular privilege exec mode. And I'll just do the normal abbreviation on this one, which is copy but start. Now we're supposed to go and create some VLANs on each particular switch. So it looks like S1 and S2 are both configured with the exact same VLAN configuration. So I'll go to S1, I'll go to the global configuration mode, and then see if I can type in, punch in those lines. Okay, that appeared to work okay. I'll go to S2 and go to the global configuration mode, and put in those lines as well. Now, down in the bottom third of page 4, little letter B, we're supposed to type in some VLAN addresses, and these differ for each switch. The first switch is going to be .2, and the second switch is going to be .3. So I'll go to the first switch S1, go to our global configuration mode, and then specify interface VLAN 20. That's the management. It's going to be the management subnet 10.20.0.2, 10.20.0.3, so forth. And so we're at the config-if, and we're going to type in the IP address of 10.20.0.2 and then 255.255.255.0. Do a no shutdown on that VLAN. And then we're going to type the exit command to go back 1 level and type the command IP default gateway 10.20.0.1. That's the friendly neighborhood router, in this case R1 for S1. So if you want to ping, if you're at the command prompt or you secured shelled or something into the switch S1, you should still be able to ping any other devices, not just devices on your own network. If you didn't put this command in, that wouldn't work. You wouldn't be able to ping anybody but people on your own network. Okay, and then the bottom paragraph of page 4, we're going to do a similar setup. Their global configuration mode, and then this says, let's say, interface VLAN 20, is it 20? And then we're going to give an IP address of 10.20.0.3/24. From the no shutdown operation, exit back 1 level, and then we'll do the IP default gateway command And this router also has the same default gateway as the other one, because they're on the 10.20 subnet. We should have full connectivity between those devices. They should be able to ping each other and ping other devices on the network. Now we are instructed at the top of page 5 to take, it's considered good practice to take ports that you're not going to use and place them in a sort of a garbage VLAN. He's calling that the VLAN parking lot, and then shut down the ports. So someone manages to get into the wiring closet and plug into a port number, it won't be active, it'll be shut down, and besides it's assigned to a VLAN with no connectivity, so they shouldn't be able to mess and get into your system and do anything. So let me go to S1 and go to the regular privilege exec mode. Got our annoying Cisco annoyance there. And S1, we're instructed to do at the top of page 5, using the interface range command here, which is very convenient. That way you don't have to type in 20 different ports here and shut them down. I'll go to the global configuration mode and then see if it can allow me to punch that in. So we get some messages on the screen there. He's looking at all those ports that we're not going to use in this particular lab, and he's not using them. I'm going to skip ahead and do part B just to show this one. Let's do show Vlan Brief. Because the only ports that are in use on switch 1 are port 1, which goes to the other switch, port 5, which goes to R1, and port 6, which goes to the PC-A. All the other ports have been placed in the parking lot mode, and if we do the show interface status, you can see that all those are disabled. Ones we want to use. If I do show up a interface brief, the normal command, yeah, they're all administratively shut down. Everything except port 1, port 5, and port 6 are the only ones we need on that particular switch. Okay, let's do a similar thing now on switch 2. And he has a slightly different range of interfaces because in the Cisco standardized topology for labs, port 6 is of switch 1 always goes to PC-A, and port 18 of switch 2 always goes to PC-B. So when I put in my interface range commands on this particular one, I want to make sure that I do those range and don't shut them down accidentally. Like if I shut down port 18, that wouldn't work. So I kind of go to global configuration mode, and will he allow me to type these in? There we go. Now we see all these ports are shut down. And then let's double check with the show command, and let's show Vlan Brief, and we can see that ports 1 and 18 are allowed to be operating, and port 5, what happened to port 5? Oh dear, port 5, port 5 needs to be done, needs to be, we'll do the no shutdown command on port 5 later. I think that's what's going to happen there. Okay. Let's go, I don't like that looks of that finger. I'm going to go to interface F0/5 and say switch port, access, VLAN. That's going to be, he's going to be a trunking port. So I don't have to change that. I shouldn't have to change that. It's going to be switch port, mode, trunk, I think, is what he's going to be. Getting ahead of myself here and doing this. 5 is going to be the wire that goes to the other one. Okay. We should be able to go to trunking now. We're going to configure trunking. So I'm going to be on switch 1. We're going to configure the trunking on switch 1. So let's go back to switch 1 and go to the global configuration mode and say interface fast Ethernet 0/1. That's going to be the wire that connects to switch 2, and we're going to configure trunking on that port. Okay, so switch port mode trunk will turn on unconditional trunking on that port, and we're going to do the same thing on switch 2. So I'll go to the configuration mode on switch 2, and say interface fast Ethernet 0/1 and switch port mode trunking. And now they should be trunking up with each other. Just to check on that, I'll say a show interface trunk. And we see port 1 is trunking. And let's check the same thing on the first switch. So show interfaces trunks. And we check with the other command. We don't show interface status. I like that command because it shows you all in one fell swoop here what's going on. What VLAN is assigned to is a trunking port. So switch 1, 1-to-1 is a trunking port. 5 is going to go to back to R1. We're going to make that a trunking port later. Switch 2, show interface status. 1 is already trunking back to 1 of the other switch, and 5 is going to go to the other router. Okay, so we checked with the interface trunking and 1-to-1 is set, and now I'm going to sort of down to the middle of page 7, and we're going to configure that fast Ethernet port 5 now on this router. So I'll go to the global configuration mode and specify interface 0/5, which goes back to the router. And the router, we're going to do some inter-VLAN routing on the router. So I need to make that a trunking port to go back to the router. So switch port mode trunk, switch port native, T interface fast Ethernet 0/5. So I did switch port mode trunk. Now I'll do switch port trunk native VLAN is 1000 is our reserve VLAN for the native VLAN. This is the thing that if you don't match the native VLANs on all the switches and all the routers, you'll get persistent error messages. Oh, Cisco Discovery Protocol has detected that the native VLAN is not the same on all the devices. You only get only one instance of a native VLAN. It's got to be the same everywhere. It's normally number 1. We've been moving it to 1000 in the newer Cisco curriculum. Now let's allow which switch ports trunks are to be allowed. Switch port trunk allowed. We're going to allow VLANs 20, 30, 40, and 1000. And then we're instructed to do a copy run start. Okay, and I guess we're going to do something like this on R2 a little bit later. He's not giving it to us right now. We're supposed to go now to the routers and do some configuration on the routers. So I'm going to switch the console cables. Now, if I go to the top screen, it should be R1. Oh, it has a password. Good. That should be Cisco. Go to the privilege exec mode with enable. It should be class. Looks like R1's good. Now let's go to R2. Password should be Cisco. Go to the privilege exec mode. It should be class. So we're logged into R1 and R2 now. And we're instructed to, well, I did already turn down. And now here's, for example, here's the part 4, step 1 in the bottom third of page 7. It says interface G0/0/1. Because this lab was written with the 4000 series routers that have the 3 numbers in the gigabit description, and the routers we use here in the physical lab are the model 1941 routers, and they're G0/1 and G0/0. But that port's already shut down. We could prove that by doing show IP interface brief, and we can see that port 0/1 is already shut down. I did that at the very beginning of the lab, so I could use my little trick of show Cisco Discovery Protocol neighbors to make sure all the wires were plugged together properly. Now we're going to go in and punch in some of these sub interfaces. So I'll go to configuration mode. Specify interface gigabit 0/1. If I try to do 0/0/1, he would go, what? I don't know what that kind of thing is. So 0/1. I didn't type it properly. I'll try. It'll still issue the error message. Stock configuration terminal interface gigabit 0/0/1, which doesn't exist on this machine. He says, no, I don't know what that is. So we're going to go interface gigabit 0/1, which is what our physical router has on it. And then we're going to put in some the sub interfaces on R1. And let me see if this is going to allow me to copy this. So I should be at, let's see, I better do one level of exit here. So I'm at the plain mode here, and then see if it allows me to pop it in there. Oh, good, there were no errors. Okay, so we put in with the commands of encapsulation.1q 20, 30, and 40, we put in these particular networks. And we're going to check with show IP interface brief in a minute, but first of all, we have to put in a loopback port because there's a fake loopback port on R1 that we can ping, or after we put in some access control list, maybe we can't ping it, depending on what the rules were. Let's go and go back to the global configuration mode and say interface loopback is number 1. And IP address of the loopback port is I didn't do logging synchronous, so all the annoying Cisco grams are popping up in my face and chopping my commands in half. But they did tell us to do that. So IP address is given as 172.1.1 and /24. Don't have to type in the shutdown command on the loopback port because loopback ports are born activated. I can shut it down if I want to, and then do a shutdown and bring it back up again. But just like the 127.0.0.1 on your desktop PC, it's always on, it's always active. Now let's check. Do the command show IP interface brief. Make sure that our numbering is correct here. It should be .20 should be 10.20, 30 should be 10.30, 40 should be 10.40, and the loopback port is 172.16.1.1. Okay, and as an alternative to this command is okay, but it doesn't show you the subnet mask. So if you made a mistake in typing the subnet mask, you wouldn't be able to see it in this. So here's a command they don't usually tell you to do in the labs, but I like it. It's easy to type. It show prot. We can see over here that the IP addresses are correct, but they also has the /24s on them. So we know we did type in 255.255.255, for example. So that can catch errors like that. Now we're going to go to let me go ahead and save that, just in case. The electricians are here, working in the building. You never know when the power is going to die. There we go. Okay, now we're going to go over to R2, and I'm sort of in the bottom half now of page 8, and we're going to configure R2's 01, not 001. So I'll go to the global configuration mode on R2. And I'm going to give him an IP address, and he's supposed to get an IP address of 10.20.0.4 and a /25. Oh, I mistyped it. I wasn't IF. Look at that. Okay, so I was supposed to say interface gigabit 0/1, not 001. And now we can get the IP address. Address of 10.20.0.4. 255.255.0, and I think I already did a no shutdown on this for CDP, but I'll just do it again. And then we're going to put in a default static route. So this has a way of getting back to the other router, which is 10.28.0.1. So IP route, be in the config mode. IP route quad 0. Any IP address, like 0000 is a wildcard, any IP address. Quad 0, any subnet mask, any network of any size, anywhere in the entire universe, 10.20.0.1, and that's our next IP address. The only thing that's not in the routing table specifically are /24 routes. They normally that traffic would be dropped, but in this case, the default route will pick it up and it'll be selected. Selected a path that goes towards 10.20.0.1. They didn't tell me to, but I'm going to go ahead and do a copy and start. Now, the next step is at the bottom of page 5, we're going to configure remote access. And the reason they're putting in this remote access secure shell is they're going to give us some business rules later on where certain people are allowed, from certain networks, you're allowed to secure shell to certain devices. From other networks, you're not allowed to go to those particular devices. And you can ping some things, and you can't ping other things. There's going to be some business rules they're going to give us for us. So we're going to go to both routers, R1, R2, and both routers, S1 and S2. And we're going to punch in this code that says username. I'm going to change this slightly, and instead of typing this weird upper and lower case and symbols and stuff, just to make sure I don't type any typographical errors, I'm going to make the username Cisco and the password class. Just the username is the username of Cisco, password is class, and that way it should be easier for us to read and see this stuff. Okay, so let me copy this material, copy it to the clipboard, go to R1. Let's go to the configuration mode on R1 and see if this is going to take this command. Okay, so it looks like the command was accepted properly. We've created the username Cisco with the password class. You have to have some domain name that's entirely arbitrary. We just use CCNA Lab. And then we generated a key pair because the secure shell process requires a key pair as well as the if you set up a web server, IP, HTTP secure server, you have to have a public-private key pair generated for that to work properly. So that's been generated on that one. And then let's also do that. We're supposed to do that on all the devices. Transport input data. Okay, I did all those lines. Okay, good. Now let's do this on R2. Same thing on R2. I'll go to the configuration mode on R2, and then let's put those lines in. Okay, work properly. I'm going to have to swing my cables over to the switch and do it on the switch because there is a ping table and a secure shell connection test yet to test our access control language permits and denies, and they have to be on the switches too. So I'm going to swing my wires over to the switches. So that code should go on the switches. So here I'm at the switch. Go to the global configuration mode. Let's see. Looks like it worked okay. And let's go to the global configuration mode and put that in. Just to check on that's not right. Show running configuration, please. Just want to check real quickly on S2 and down at the bottom. See if the password lines were accepted. Okay. Now we've done S1 and we've done S2, and now at the near the top of page 9, I have to go back to R1. We're going to put a secure web server function. We're going to put a secure web function on R1. And we're going to put an access control in there and see if we can meet our business needs. See if this is going to work on the real devices. Okay, is this back on R1? It looks like it is. R2, all right. Okay, so we're instructed to go to the global configuration mode of R1, enter some code, IP, HTTP, secure server. And this did not work on Packet Tracer. Packet Tracer will not work with this command. And then we're supposed to go IP, HTTP, authentication, local, which means use that username and password that we created, username Cisco password class. That will be the password that'll log into if you're asked for a password to go to the secure server. Okay, now let's go over and look at our host machines. I pre-configured the IP addresses on them, but let's just check and make sure they came out properly here. So PC1, PCA is supposed to be 10.30.0. PCA is 10.30. Oh, that's a proper address. I got to fix that. So we're on PCA. Go to here. So PCA is determined to be 10.30.0. It should be 10. Now I'm going to start at the beginning of this because I'm going to show you there's a gotcha in the real Windows. So I'm going to clear the address out. PCA is supposed to be 10.30.0.10. Now when I press the tab key, look what happens. It looked at that first digit of the address. 10 is the old legacy class A address range, which is a /8 or 255.0.0.0. So I have to type 255.255.255 because he tells us the subnet mask is 255.255.255.0. And then 10.30.0.1 is the default gateway for PCB. So click OK, click close, and we repeat this command. 10.30.0.10. Now let's go to PCB and check him. So he's 10.40.0.10. That's correct. It's 255.255.255, 10.40.0.1. And just for fun, can I ping my own default gateway? Not yet. I haven't done all the trunking and stuff yet. Okay, let's go back to PCA. So the IP addresses on those are set properly. Let me minimize this. Okay, I want to go back to R1 and let's do the show IP routing. And that's proper. Okay, good. And we'll go to R2 and do a show IP routing. And I thought we had put in a default gateway on this. Let's see what's going on here. It must be port 5 of switch 2 is not up and up, and G01 can't come up because if I do a show run, we'll go to gigabit 0/1, and he's not shut down. Okay, so let me go to the switch 2 and let's correct that. We'll leave R2 at the bottom, and now this should be S2 at the top. And let's do a show IP interface brief here. So port 5. Oh, port 5 is administratively shut down. Okay. And let's make it configuration mode. Interface Ethernet 0/5. No shutdown. And let's do a show VLAN. Isn't he stuck in the raw kind of a VLAN? I think he needs to be into the regular VLAN. So configure terminal interface fast Ethernet to 0/5. Oops. And switch port mode access, switch port access VLAN 1. And it looks like the port 1 came up on this. So if I do a show IP interface brief now, oh, wait a minute, do the show routing table. Let's do the show routing table. Okay, so our static route is installed. 10.20.0.4. Can I possibly ping 10.20.0.1? Can't do that yet. Okay, hang loose, I'm gonna check for that. So the issue here is between port 05 on the switch and G001 on the router. There's no inter-VLAN routing on R2, it's all on R1. So let's look at S2 and what is the status of port 5 here? I think about being mistaken in the lab procedure. S2, he told us to put it in 999 and shut it down. And I don't think he ever told us to put it back in. I don't think he ever told us to put it back in the proper VLAN for this. Let's go to S2 and see if he's able to ping. Can S2 ping, for example, can he ping 010.20.0.1? That's fine. Can he ping S1, which is 10.20.0.2? That's fine. Okay, so S2, the path from S2 to S1 to the router looks like it's good. It's working properly that way. So can S2 ping, what's R2's address? 10.20.0.4. Okay, so there's some issue between the fast Ethernet 5 port of S2 and gigabit 001. So again, I want to do a show interface status just to check on that port 5. And port 5 is connected, and he's in VLAN number 1. And we're not supposed to be doing any trunking here. And what is the IP address of R2? 10.20.0.4. So he must need to be in VLAN 20. That must be the issue. Let's try and see if that fixes it. So I'll go to the global configuration mode and go to interface, fast Ethernet 0/5, and switch port, access VLAN 20. And see if that makes him happy. So the ping request we had before was this. Not any happier. So if I go to router R2 and do a show IP interface brief, so G01 10.20.0.4, can he ping 10.20.0.1, the router? Oh, look, it started working. Oh, I know what stopped working. Oh, it's the 50 seconds for the STP. Okay. So he's still not coming up properly. So S2 cannot ping 10. It's 10.30. Ping 10.20.0.4. Okay, I just messed up the address. Okay, I think we've got good connectivity here, so we're ready to do, before we apply any access control list, we're going to go to page 9, and we're going to try some ping tests and so forth, and they should work properly. So I'm instructed to go to PCA, so let me go to PCA. And we're at the command prompt, and I'm supposed to be able to ping, I'm at the chart in the, starts at the bottom half of the page of page 9. I'm supposed to be able to ping 10.40.0.10. And we're not getting the goodness. Let me see if I can ping 10.20.0.1. Okay, PCA is plugged into port 6 of S1, and he's assigned a 20, so he should be on VLAN 20. Let's check that port 6 on switch 1 and see if they forgot to tell us to do something with that. Okay, I'm going to put I'll put S1 at the top here and move S2 down to the bottom. this S1. Oops. S1, go to privilege exec mode, class, and we'll do a show interfaces status. What's going on with port number 6? Oh, they forgot to tell us to move port 6 over to VLAN 20. Oh my goodness gracious, well that would cause this problem, wouldn't it? Okay, so let's go to the global configuration mode. Interface 0/6, switch port mode, access, just to make sure it's an access port, switch port, access, VLAN. Okay, here we go. Now, I wonder if that's going to fix them. Let's see. Oh, it may take 30 seconds for the lights to come up. The light is still orange. Because when I change his access port to a different VLAN, he has to go into the STP searching mode and search for any problems on that VLAN 20 network. I'm watching it. It's going to turn green here in just a second. And let's see if that fixes the problem. Okay, it's now turned green. Now let me check my IP configuration here. Let's see, IP config. Am I supposed to be, oh, I'm 10.30. I'm not 10.20. I'm 10.30. It should be VLAN 30, not VLAN 20. That's silly. Let's fix that. That should be easy to fix. So I'll go back to TerraTerm and go to COM1 and say switch port access VLAN 30. And just to give it a kick, I'll shut it down and do a no shutdown again. Okay, and I'm going to, when I set the light's gone orange, and let's see now if the light goes green again. It's working properly. I wonder if they got that code correct in the answer key and they just made a mistake when they wrote the lab procedure. Let's see what it says here. Port number 5. Or rather, port number 6. Port number 6. VLAN 30. It does say VLAN 30. In the back of the answer key with the final ILS listings, that is correct. They do have that code in there. It's gone green. And it's working. Okay, good. Okay, so I did from PCA, I was able to ping the those two devices. Now let's go to PCB and let's do some testing from him. Okay, PCB was supposed to be able to ping 10.30.0.10. And let's check the VLAN assignment for PCB. PCB is a 10.40. He shows you it should be on VLAN 40. Let's go. Am I connected to S2 here? Let's do a show interface status. And let's check on what's happening with port 18. Port 18 is assigned to VLAN 1. So it needs to be corrected. And that probably should be VLAN 40 since that PC is a .40 in the third octet. Checking on my answer key now for port 18. Port 18 is VLAN 40. Okay. So I'll go to the global configuration mode and go to interface fast Ethernet is 0/18 and switch port mode access and then switch port access VLAN. And that will probably cause him to go orange because we put him in a new network, and STP now must do a quick 30 to 50 second search for any other loops in the network. And then once it turns back to green, maybe our test will work properly. And he's blinking orange, and he's blinking orange, and he should start blinking green here just in a second. Okay, he has turned green. Okay, let's see what's happening now. Oh, good, we got a reply. Okay. Okay, PCB can ping the 10.30.0.10. The next test is PCB should be able to ping 10.20.0.1, which is this friendly neighborhood router. And next of all, it should be able to ping that 172.16.1.1 address. The loopback port on the router, that's working just fine also. Okay, great. Now PCB is going to be doing a hypertext transfer protocol secure to 10.20.0.1. I can ping it, but can I do a secure shell thing to it? So what I'm going to do is put away my DOS prompt and bring up the web browser and tell the web browser to go out to https://10.20.0.1. Okay, and I'm going to say, yes, go ahead. It's just an unsigned thing. Advanced. Yes, go ahead. Accept the rest and continue. Yes. And the username is Cisco and the password's class. I'm not going to save it. And we got some sort of connection here. This is an older version of Firefox. All right, so let's go and do the 172.16 and see what happens with this. I'm still supposed to be on PCB? Yes. So I'm going to go https://172.16.1.1. Go to the advanced mode. Go to exec risk and continue, Cisco class. And we're sort of getting some sort of weird connection here with this old software. So, let's try secure shell now. We're going to go to PCB. We're still on PCB, aren't we? Still on PCB. And we're going to start the TerraTerm program. This is the only time we use TerraTerm within PCB VMs here in the classroom because they have a secure shell function in them. So secure shell, and the actual IP address is 10.20.0.1. Let's see if they'll give us some sort of connection. Okay, Cisco password. We'll go ahead and accept the key exchange. He jumped on me right when I was putting the password class. And we are officially connected with the official warning. The bad message of the day appeared. So the key exchange is working properly with the secure shell code. That seems to work fine. And then we also want to do the same thing with, I'll disconnect this, start it again. And we're going to go this time to the address 172.16. Not that one. Secure shell, connect. Cisco. Okay. Cisco class, and we're connected. Okay. Okay, so all tests are successful. A little bit of weirdness there with the HTTPS and the old version of Firefox on our old VM machines here. Now we're going to do, on the bottom of page 7, we have 4 policies that upper management has decided, like the sales network and secure shell, etc. So at the top of page 10, there's a couple of access lists. The first access list, 101, and this is going to be on R1. Am I still connected to R1? I think I have to move my connection back to R1. Cisco. That's connected to R1, and we're going to poke in one access control list that incorporates policies number 1, 2, and 3. And if I constructed this properly, let's see if we get any errors. Oh, I have to be in the global configuration mode. Okay, if we do show access lists, there's our arbitrary code here, and it's 9 lines. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like it's okay. And now we're going to punch in another list on R1, access list 102. That's going to be policy number 4 of our arbitrary policy we were given in the lab. So I'll go back to R1 and make sure I'm in the global configuration mode. And then I'm going to do a copy run start and save that to the configuration. Now, let's see if by any possible chance here, all the errors I have in the procedure for the lab, is this going to be actually possible for our fails and successes to work properly from a PC-A and PC-B. So let me see, I'm supposed to be at PC-A, and we're supposed to try to go to the address 10.40.0.10, and we're not able to get there. We're not supposed to get there. It's supposed to be a fail. On the other hand, we should be able to ping 10.20.0.1. And it worked properly. All these things worked properly before, but now we were instructed to do some security on those. Okay, let's switch over to PCB. Get rid of this, disconnect, bring up our DOS prompt. Okay, we're present at PCB, and we're supposed to try to ping 10.30.0.10. And it doesn't work, and it's not supposed to work. It's supposed to fail. Now let's see if we can ping 10.20.0.1, the master. That one's supposed to work. Now let's see if we can ping 10.30.0.10. That's supposed to fail. And then we can ping 10.20. Oh, PCB 10.20.0.1 is supposed to fail. I was looking at PCA in the first column. Okay, so this is working properly so far. Now, we're supposed to be able to ping successfully 172.16.1.1. And that does work successfully. Now, we are not supposed to be able to go to the secure web browser. So let me bring up the secure web browser. And we're going to go to the address https://10.20.0.1. And we're getting a failure. It's not connecting to it. It's good. It's being blocked. I think that it was supposed to be blocked like this. Well, okay. How about the address https://web72.16.1.1? That's working. We're getting prompted for the name and the password. Okay, that's working properly. Now let's go to the secure shell and see what secure shell is working now. Before secure shell, we'll use term. And secure shell address is given. The first one, which should work, is 10.20.0.4. You're trying to connect. And the one that's supposed to fail, oh no, that's supposed to fail. 10.20.0.4 is supposed to fail. Okay. Now let's see if the one that's successful is going to be successful. So far everything's working okay. 172.16.1.1 ought to work. It's working. We're being prompted. Okay, that's working properly. Okay, good deal. So things to watch out for in this lab. You got, by the way, you guys don't have to do this lab. This is a lab demo. I've already put the grade 0.99 as a placeholder check mark thing in your my TCC Blackboard gradebook. And so in these newer labs and new curriculum, there are occasional errors found, and we found a few in this procedure, even though the answer key at the back with the final iOS listings does appear to be correct. Okay, so if you were actually doing this in the lab at this point, you would erase S1 and S2. And I'm going to go ahead and illustrate that now with S2. Well, S2, I'm on R1 now. I still on S2. And if we do a show run, have an existing configuration. And if we do show VLAN, we've had some VLANs. And if I do the directory command, I can see there's a file there called vlan.dat, so I need to delete that. Setting 3 times, and then I need to do erase the startup configuration. That takes care of S2. I'll go back to S1 and do the same thing. So if we do the dir command, we did create VLANs on both of the consistent VLAN tables on both switches. So I need to delete the VLAN that file. And I need to erase file. Okay, S1 and S2 are deleted, and I'll go back to R1 and R2. Okay, top one should be R1. And if we do is show me the startup configuration. Show me the startup configuration. Yeah, we did make a save here. So we need to do the erase start to get rid of that. So I'll erase the startup configuration. I'll go to R2. And show me the startup configuration. And there was one that was saved, so I'm going to do an erase start. Oh, let's see. Someone had participating synchronously. The question is, this lab has been graded as 0.99. So you do not need, Mr. Lang, you do not need to submit the lab. I'm doing this as a instructor demo. So everybody gets full credit for this, whether they attended the class or whether they watched it asynchronously. So you don't have to worry about that one. Okay, we've completely gone through the lab. We have verified that it worked mostly. There were some errors in the lab procedure, but the answer key was correct, and we had to change the VLANs on a couple of ports. They just neglected to tell us that. Then we erased both switches and we erased both routers, so these devices are not ready for the next class to use them. And I think I've pretty much done this. Okay, so I'm going to stop the taping.